This is something based on geometric series. Let's say we have a container as shown here with a 5-liter capacity, and every day I pour in water every 24 hours, let's say, and each day, every 24 hours, 70% evaporates. 70% evaporates after 24 hours. So again, next day, I this amount poured in is 2 liters, let's say. Then after 24 hours, 70% evaporates. Again, I add 2 liters. Then 70% of whatever is there evaporates. Then again, I add 2 liters and so on. The question is, will it overflow at some point? The capacity is 5 liters and I keep adding 2 liters every day with 70% evaporating every day. It's a regular time period, let's say 24 hours. So the question is, will the container water overflow from the container? Now let's take this step by step. Let's say after the first day, or after 24 hours, what is the status? So 30% will remain because 70% evaporates. 30% or 30 by 100 or 0.3 remains of the water that is originally there, the 2 liters. And again, I'm going to add 2 liters after 24 hours. Then let's say after 48 hours, what would happen? Whatever is here, 0.3 times 2 plus 2, of that 30% would remain. So 2 0.3, 2 times 0.3 plus 2, of this 30% would remain 0.3. Then I'm going to add 2 liters again. Now let's simplify or evaluate this a bit. This becomes 2 times 0.3 square, because there's 0.3 here and a 0.3 here. I'm expanding that, plus 2 times 0.3 plus 2. Now this is the term I get. Now this initial term was 2 times 0.3 plus 2. So let's mark this. Then let's say after 72 hours, what would happen? After 72 hours, or rather 3 days, this would be 30% of this right over here. So that will be 2 times 0.3 square plus 2 times 0.3 plus 2, and that whole thing, you take 30% of that remains, and then we add 2 liters again. Now if we expand this or evaluate this, this would simplify to, let me write it as 2 times 0.3 cube plus 0.3 square plus 0.3 plus the 2 liter that we are adding. Now if we look at these three underlined terms, we see a common pattern, that 2 times 0.3 plus 2 here, 2 times 0.3 square plus 0.3 plus 2 here, and 2 times 0.3 cube plus square plus 0.3 plus 2 here. So the term 0.3 cube plus square plus 0.3, that's the only thing that is changing each day or each 24 hours. There's 0.3 getting added to each of these terms after 24 hours. Now if you look at that alone, the 0.3 plus 0.3 square plus 0.3 cube and so on, as the days progress, this will increase to the power of 0.3 to the power n it will become. This is clearly a geometric series with the first term, let's say a or a1, 0.3, and the common ratio 0.3. Now also we know that whenever this common ratio is between, or the magnitude of the modulus of common ratio is less than 1, then it's a converging geometric series. The series would converge, the sum of the series would converge to a value a, or the first term, or a1, divided by 1 minus the common ratio. So in this case it would be 0.3, which is the first term, divided by 1 minus 0.3, which is the common ratio. This would be 0.3 by 0.7, and that we can calculate as 1.428. Now if we plug it in here in this would become 2 times 1.428 plus 2, because this is going to be a converging value. This is not going to change, very negligible, and we know that it approaches 0. So after some point it's going to be stable at 1.428. That's a converged value. So when we evaluate this, 2 times 1.428 plus 2 gives 4.856. so this would be the value at which that water level would converge as we keep pouring 2 liters every day, and 70% evaporates. Again we pour, again 70% evaporates. So it will always be at this value max. So the water will not overflow because the series would converge to a particular value of 1.428.